So today we are going to do the estimating of sock pit of a septic tank. So this is the plan of sock pit. As you can see, the inside diameter of this sock pit is 1.5 meter and it is circular in shape in the plan, and actually it is a cylindrical shape. The inside to inside diameter is 1.5 meter and the outside to outside diameter is 1.9 meter. Okay, this is 1.5, this is 20 centimeter, this is 20 centimeter. So overall outside to outside diameter is 1.9 meter. Okay, and if we look at the sectional view, then you can see the overall height is 3 meters. Up to 0.6 meter there is a brick ballast, and again there is a gap, and the second layer of brick ballast is 1.8 meter. So this brick ballast is given so that the waste liquid that comes and flows under gravity within the void spaces of the brick ballast, and ultimately it is collected in the lower chamber, which is 1.8 meter depth, and the upper chamber is 0.6 meter depth. So there are two chambers. The upper chamber is 0.6 meter depth and the lower chamber is 1.8 meter depth. Okay, and the inside to inside diameter is 1.5 meter and the outside to outside diameter is 1.5 plus 0.2 plus 0.2, 1.9 meter. Okay, so first of all let us start with the calculation of quantities for this sock pit. Okay, this sock pit is designed for 50 users. So first of all we'll do artwork in excavation for this particular sock pit. How to calculate artwork in excavation for a septic tank? We have already done that. So let us calculate the artwork in excavation for this particular sock pit. Now you can see the overall depth for this sock pit is, this is the ground level. So the overall depth is 3 meters. The overall diameter is 1.9 meter. This one, overall diameter is 1.9 meter and overall depth is 3 meters. Okay, so artwork in excavation will be pi by 4 d square into h. That is the area of a cylinder, isn't it? So as this is a cylindrical shape, we will have to apply the formula of cylinder. This is the total volume of a cylinder, isn't it? So pi by 4 d square. D is how much? I have already mentioned that D is 1.9. So 1.9 square. H, what is the height? Total height, I have already mentioned, it is 3 meters. Pi by 4 d square into h. Okay, this comes to be, I think, 8.5 meter cube. Okay, so artwork in excavation is done. So next is we have a cover. We have a cover, RCC cover of this much. So how much RCC work is associated in the construction of this RCC cover, we will have to calculate. So RCC work in cover of sock pit, which is equal to, what is the breadth? This inside to inside diameter is, I have already told you, 1.5. It is 1.5, and 10 centimeter it is inserted into this wall, and also 10 centimeter inserted into this wall. So 1.5 plus 0.1 on this side and 0.1 on this side, total 1.7. So the length is 1.7. Sorry, not length, the diameter is 1.7. So the area of the RCC slab will be pi by 4 d square, but we need volume, as concrete RCC unit of measurement of RCC is meter cube. So it is going to be placed over this portion, over this circular portion. So diameter is 1.7, 1.5, and 10 centimeter here, 10 centimeter here. So diameter is 1.7. So the area will be pi by 4 d square, and multiplied by the height or thickness of the slab, height or thickness of the cover slab. So let us assume the thickness will be 15 centimeter, that means 0.15 meter. Okay, so pi by 4 d square means 1.7 square into 0.15. Let us assume thickness is 0.15 meter. So this comes to be 0.34 meter cube. So this is the quantity of RCC slab which is placed as a cover over the sock pit. Okay. So the next item is Jama brick ballast. Jama brick is a very low quality brick of 10 millimeter size broken bricks, which is placed inside the sock pit as the first layer. As I have already discussed in the drawing, this is the first layer. This is the first layer, and it's a height of 0.6 meter, that means 2 feet. These are the Jama brick ballast, and we need to calculate how much brick ballast is required to fill up this height of 0.6 meter. This is the first layer. This is the first layer of height 0.6 meter. 0.6 meter. So how much brick is required to fill up this first layer of 0.6 meter? Again, we know the inside to inside diameter. This is the inside to inside diameter is 1.5. So, and the height of the first layer is 0.6. So inside to inside diameter is 1.5 and the height is 0.6. So we can easily calculate the volume, which will be equal to pi by 4 d square into h. Again, d square diameter is 1.5 and h is 0.6, as I have already discussed. So let us find out how much is this one. So this comes to be 1.0597 meter cube. We can take it as 1.06 meter cube. So this much of brick needs to be filled in the first layer, that is this first layer. So we need to calculate how much. Now we need to calculate how much brick needs to be filled in the second layer, and the depth of the second layer is 1.8 meter and the diameter is same as 1.5. Yeah. So let us calculate. So diameter is same as the first layer, but only the height is different. Height is 1.8 meters. So again, the same formula we will apply, pi by 4 d square into h. That's the volume of a cylinder. Pi by 4 d is 1.5. We know that. Height is, I have already told you, height is 1.8 of the second layer. Second layer height is 1.8. So 1.5 and 1.8. Let us find out how much is this one. So this comes to be 3.179 meter cube. We can take it as 3.18 meter cube. So that's how we calculate. One more very small item is left. There is an RCC slab, small RCC slab, this one. This small RCC slab is provided to support this inlet pipe. This is the inlet pipe. So over this RCC slab we will place this inlet pipe. So we will have to consider this RCC slab also in this estimate. So as you can see, the length of this RCC slab is 1.7, as this diameter is 1.5, 10 centimeter on either side it will be inserted. So total is 1.7. Total length of this RCC slab is 1.7. Okay. So RCC support for inlet pipe in the sock pit, length 1.7, as I have already told you, and breadth and thickness both we will assume. Breadth is suppose 0.2 meter, that means 20 centimeter, and the thickness of the wall is 10.1 meter, that means 10 centimeter. We have assumed both these quantities. There is no fixed value. There is no fixed value for these two. We can assume, easily assume. So breadth we have assumed 20 centimeter or 0.2 meter, and thickness we have assumed to be 10 centimeter or 0.1 meter. So the total quantity will come as length into breadth into thickness. 1.7 is the length, 0.2 into 0.1. Ultimately, the quantity of the RCC support, RCC slab, which is provided to support the pipe, is 0.03 meter cube. This is how we calculate the quantities of a sock pit.